Compound areas. Areas made up of two or more shapes. In this video, we will focus on compound areas made from rectangles. When looking at shape, one thing that we can measure is length. So we usually use something like a ruler to measure the length or the height or the width of an item, okay? If you actually measure the length of the button number 5 on your calculator, it's roughly about 1 centimeters in width or length. Do you see that? Okay, so that's length. Also, when looking at shape, we can measure the flat space it takes up. This is called area. So here we have a square. Because it's a square, that means both sides have equal length. And here, the length of both sides are 1 centimeter. So the area of a square is length multiplied by length equals length squared. And we say length squared because it represents the shape of a square. So if I looked at this square here, the area of this square is 1 centimeter multiplied by 1 centimeter equals 1 centimeter squared. So it's 1 because 1 multiplied by 1 is 1. And a centimeter by a centimeter is a centimeter squared, i.e. it's a square whose lengths are 1 centimeter. Okay. So example number 1. Find the area of the following compound shape. So the thing to remember is that compound shapes are made up of two or more shapes. Here we can see this compound shape is made up of two rectangles. So what we're going to do is we're going to label the two rectangles, A and B, and then we're going to get the area of rectangle A and the area of rectangle B and add the two answers together. So what we need is the formula for the area of a rectangle. You can see it over here in the orange. So the area of a rectangle is the length multiplied by the width, or the length by the breadth is sometimes said either. So using that formula, let's get the area then of rectangle A. So the area of rectangle A equals 2 centimeters multiplied by 3 centimeters. Okay, so you can see the 2 here and the 3 here. Now, if you write down 3 centimeters multiplied by 2 centimeters, that's totally fine. You will get the same answer. Okay, so 2 centimeters multiplied by 3 centimeters equals 2 by 3 is 6, and centimeters by centimeter equals centimeters squared. So my answer is 6 centimeters squared for area of rectangle A. Then the area of rectangle B equals 2 centimeters multiplied by the 8 centimeters equals, so that's 2 by 8 is 16, and centimeters by centimeters is centimeters squared. So these are the areas then of my two rectangles, and all I do then is add those two areas together. So 6 centimeters plus 16 centimeters makes 24 centimeters, and that is the area of my compound shape. Now example number 2, find the area of the following compound shape. Now if you look at this shape here, it looks like it's made up of two rectangles again. So what I'm going to do is I'm going to draw a line there and divide it into two rectangles, A and B. Now, if you look at it this time though, it's not so clear cut, because if I look at rectangle B, I can see that it is 5 centimeters wide and 9 centimeters high, which is enough then to get the area of that rectangle. But if I look to the rectangle on the left, rectangle A, I can see that it is 7 centimeters high, but I don't know what width it is. The 14 centimeters spans the width of both rectangles. So what I'm going to do is I'm going to move that 14 centimeters, and I'm going to look to the top of rectangle B, and I can see that that's 5 centimeters at the top. So that means that the bottom of rectangle B is also 5 centimeters. Now, if I compare the 5 centimeters with the 14 centimeters, I can see that I've used up 5 centimeters of the full width of the shape. So what I'm left with is 14 take away 5 is 9 centimeters. So that will be then the width of rectangle A. So now I have enough information to separate out my two shapes that make up this compound shape. rectangle A and rectangle B. So I'm going to use my formula. Area of a rectangle equals length multiplied by width. So then we're going to get the area of rectangle A. So the area of rectangle A equals 7 centimeters multiplied by 9 centimeters equals 63 centimeters squared. So 7 multiplied by 9 is 63, centimeters by centimeters are centimeters squared. And you can do that on your calculator with the numbers if you're a little unsure. Then area of rectangle B equals 5 centimeters multiplied by 9 centimeters. So 5 multiplied by 9 is 45, centimeters by centimeters are centimeters squared. So then the area of the full compound shape will be adding those two rectangles together, and that gives us 108 centimeters squared for the area of the whole compound shape. Now example 3, find the area of the following compound shape. So you might look at this shape and see 3 rectangles all joined together to make a backward C. Or maybe you see it as one big rectangle with a little rectangle cut out from the side. So what we're going to do is we're going to focus on the second option there. Now first of all, what I'd really like to know is what is the full height of this shape. So I'm going to focus on that gap on the left hand side and fill it in. Now if you can see on the right hand side, we know that that height in the middle is 4 centimeters. So we're going to say that the height then of the gap is also 4 centimeters. Now on the left hand side, I have enough information to figure out the full height of this shape. So it's going to be the 2 centimeters at the top, the 4 centimeters in the middle, and the 2 centimeters at the bottom. So if I add those 3 heights together, I can see that the full height of this shape is 8 centimeters. Now what I'm going to do is I'm going to focus on this little rectangle in the middle. And what I want you to do is in your mind's eye, imagine cutting that rectangle out from the big blue rectangle. Okay? So what we're going to do here is we're going to call the big blue rectangle, rectangle A, and the little white rectangle, rectangle B. Okay. So what we're going to do now is we're going to try and find the area that's left over after you cut it out. So that means we'll be taking the little rectangle away from the big rectangle, so we will be subtracting. Okay, so first of all we need to get the area of the big blue rectangle. Imagine it as a big piece of blue paper. So using our formula, the area of a rectangle is length multiplied by width. So the area of rectangle A is 8 centimeters multiplied by 7 centimeters equals 56 centimeters squared. Then looking at the part that we're going to cut out, rectangle B, the area of rectangle B is 5 centimeters multiplied by 4 centimeters, so that equals 20 centimeters squared. So remember, we're cutting out, so we're subtracting. So 20 centimeters from 56 centimeters is 36 centimeters, and that's going to be the area of that piece of blue that's left after we cut out the rectangle. Okay. Now, example 4, find the length of the perimeter this time of the following compound shape. So that is the length of all of the sides added together. So the first thing we're going to do is, again, we have to figure out the height of our shape. So if you remember, the 4 fills in that gap on the left. So then we knew the full height here was the 2 centimeters, add the 4 centimeters, add the 2 centimeters, makes a height of 8 centimeters. But now we won't be filling in that gap as part of our perimeter journey because we're only looking at the edges of our compound shape. But what we do need that 8 centimeters for is the other side, because we're going to be looking at the length of that side when we're adding it up to make our perimeter. Okay? And then looking at this, the only side that I'm missing then is the very top of my shape. But you can see that the top of my rectangle should be the same as the bottom of my rectangle. The bottom of this big blue rectangle is 7 centimeters, so the top should also be 7 centimeters. So now as I look at it, I think I have filled in every single length along the edge or the perimeter of this compound shape. So now what I do is imagine yourself walking around the whole perimeter and adding all the sides as you go. So what I like to do when I do perimeter is I pick a spot to start at, and then I start adding all of my numbers together as I walk around the outside of my shape until I get back to where I started from. So if we go from left to right here, we're going to start walking, and the first side that we're going to meet is the 7. So take the 7, and then we're going to walk up along the 8 centimeters. So we're going to add in that 8 centimeters. Then we're going to walk left along the 7 centimeters. So add the 7 centimeters on. Then we're going to walk down the 2 centimeters. So add the 2 centimeters on. Then we're going to walk again right along the 5 centimeters. So add the 5 centimeters on. Then we're going to walk down along the 4 centimeters. So add the 4 centimeters on. Then we're going to go back along the 5 centimeters, add those 5 centimeters on, and then we're going to come back down on the 2 centimeters back to where we started. So add those 2 centimeters on. So that is a full list of all the lengths that I have walked along. Add them all together to find the full perimeter of the shape. So it's 40 centimeters long. Now be careful, not centimeters squared. We're not talking area here, we're talking length. So it is 40 centimeters. Okay, so now what I want to talk about are your copybooks. So in your copybooks, you have these lovely squares that are there to help you draw shapes. Okay, and also remember those squares will also be in your exam papers, because really we're trying to encourage you to draw. And that's because when you see a question like a compound area, it's very beneficial to try and draw it out for yourself instead of just reading the question, because it gives you a lot of interpretation, a lot of knowledge to see what exactly the lengths are. And especially if you have squares, you have a great reference there. So what I'm going to do is that last question, I'm going to do it now on a graph, and I'm going to mimic how you would put it into your copy using squares. Now, because I'm using a graph, I'm extra lucky because I can use coordinates as well when I'm drawing my shape. And that will be a nice little refresher for you on how to use coordinates. Okay, so I'm going to do it just like we did the perimeter question. I'm going to pick a place to start, and I'm going to draw the full shape and go back to where I began. Okay. So let's pick a point to start at. So let's pick the point 3, 2, which means right 3 up 2. And if you remember now, first thing we did on our perimeter was we went 7 to the right. So let's go 7 units to the right. 1, 2, 3, 4, 5, 6, 7. So that'll bring me to the point 10, 2, which is right 10 up 2. Okay, now on my graph, I don't have my units specified. Just like in your copy, you don't have units specified. So if your question is in centimeters, let your units be centimeters. If your question's in kilometers, let it be kilometers. If it's millimeters, let it be millimeters. You decide what your unit represents for you in your copy. So here we're going to let these units represent centimeters. So then after 7 across, I had to go 8 up for my shape, my perimeter. So let's go up 8 units. 1, 2, 3, 4, 5, 6, 7, 8. So that'll bring me up to the point 10, 10. So right 10 up 10. Then I had to go back 7. So let's go back 7. 1, 2, 3, 4, 5, 6, 7. So back 7. So that brings me back to the point right 3 up 10. Okay, so we were taken away that time, remember, going left minus 7, so we were taken away 7, so 10 minus 7 brought us over to 3, the point 3, 10. Now next, if you remember on your perimeter, we had to go down 2 units. Do you remember? So let's go down 2 units, and that will bring me to this point here, the point 3, 8. So right 3 and up 8. Then do you remember we had to go in 5 units? So let's go in 5 units. 1, 2, 3, 4, 5. Okay, so that brings me over to the point, right 8, up 8. And then do you remember that gap in the middle? It was 4, wasn't it? So we're going to go down 4 now. 1, 2, 3, 4. Okay, so that brings me to the point 8, 4, which is right 8, up 4. And then we to go back on ourselves for the 5. So back 5 units, which we're calling centimeters. So that'll bring me back to this point here. So that's the point 3, 4, which is right 3, up 4. And then finally, it was another 2 centimeters, wasn't it? Right back to where we began. So take that point and go down 2 centimeters or 2 units, and we're back to where we started. Okay. Now, you can see how much information you have from drawing it correctly into your copy. So already, one of the first things we really needed to know was what was the height of this shape. You actually would have been able to count it had you have drawn a good diagram. Look, you would have been able to just count these squares. 1, 2, 3, 4, 5, 6, 7, 8 squares. So you would have been able to tell then that the height of this here line is 8. So let's put the value in there, is 8. You also would have been able to tell the top line. Do you remember we had to figure out that that was 7 for doing the perimeter? But again, you would have just counted it. 1, 2, 3, 4, 5, 6, 7. Okay, and you would have been able to figure out what the height of or the length of that was. Let's put it in there, 7. Okay, so in fact, you would have been able to count all of these no matter which ones you were given or you weren't given. So there's our 2. This one it's 5 across, isn't that right? So that should be a 5. Let's put that in. Okay, this was 4 down, wasn't it? So let's put that in. That's 4. Okay, this one also then was 5 across. Let's put that in. This one was 2 down. Let's put that in. See how much information you have just from using your squares properly? And then the last one here is 7 across. Let's put that one in. Okay, so you would have easily been able to read off your perimeter. Remember, pick a place to start. We started here and it was 7 plus 8 plus 7 plus 2 plus 5 plus 4 plus 5 plus 2 equaled 40 centimeters. So that was your perimeter. Now, in fact, the area you could also count here as well, because the area is calculated in centimeters squared. And each of these little squares is a centimeter squared. Okay? So they're the little areas that are centimeter squared. Now that's if you're letting your units be centimeters. If you're imagining your units to be inches, those little squares would be inches squared. If you're imagining your units to be meter sticks, those all would be a meter squared. Okay, so whatever you imagine your units to be. Actually, if you measure the units in your copy, they're half a centimeter in width. Okay, so that's the actual width of them. But you can imagine them to be whatever is useful to you. So we are calling them centimeters today. So each of these squares is a centimeter squared. So let's count how many there are, because that should equal our area. Okay, so here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, then 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Then we have 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Perfect. Because if you remember, what did we get for the area of this shape? We got 36 centimeters squared. So can you now see the value of doing good diagrams in your copy? Super important, okay? Right.